All right, so this is the lesson 15 review. A few people had some troubles with this, so we wanted to make sure that you guys really and truly understood what we reviewed in this lesson so that we can move forward with some confidence and a greater understanding of what it was that we learned. All right, so number one, which correctly explains the number of solutions of the following system of equations. So what you have to do first is you have to make sure that both equations are written in slope-intercept form, which is just y equals mx plus b. All right, the bottom equation is already written in that way, so we're good to go with that one. We have to change the top one to be written in slope-intercept form. So the first thing we need to do is move the negative 3x over to the right side. And when you want to move a variable term or any term to the other side of the equal sign, you just kind of drop it from the one side that it was already on, and you'll add the opposite. Yeah, the opposite to the other side. So we'll add a positive 3x to the other side. So now we've got the 3y equals 12 plus 3x. Now all we've got to do, again, we need it in slope-intercept form, which is just a y on the side by itself. So we have to divide every single term by that coefficient to get y by itself. So now we've got that y equals 12 over 3, which is 4, plus 3x over 3, which is just x. So we've got x plus 4 equals y, and then y equals x plus 4. These are exactly the same. They are exactly the same. When you have that, that's infinitely many solutions. All right, so we've got that. So the one that has infinitely many solutions, A says no solution, so that's clearly not the one we want. B says it has one solution, not what we want. C also says one solution. D is the only one that says infinitely many. There we go. All right, and we move on. Okay, I'm going to move here. All right, so number 2, draw a line from each system of linear equations to the correct description of the solution to the system. So again, what you have to do for all of them is you have to make sure that both equations are written in slope-intercept form. Well, the bottom one, the last system of equations, is already written in slope-intercept form. So let's go ahead and compare the coefficients or the variable terms. So here at the top we have negative 3/4, and at the bottom we have positive 3/4. These are different slopes. And what we call slopes now, we used to call variable terms. And when you have that, that automatically tells you I'm going to have one solution because they're different. I don't have to look at anything else. I just know that my slopes are different. They will eventually intersect. All right, so I move on to this this first one. So the top is already done. The second one, all I need to do is move my negative 2x to the other side, so I'll make it its opposite. So plus 2x. So I've got a 7, which matches, and a 2x, which now matches. Everything matches, so that gives us, drum roll, infinitely many solutions. Obviously, the last one needs to be no solution because that's the only one left. But let's just make sure we're right. So we'll put everything in slope-intercept form. So we need to move this positive 4x over to the right. And if we're going to move it over the equal sign, then we have to make it its opposite. So minus 4x. And then here at the bottom, we just need to divide every single term by 2, that coefficient. So we'll get y equals negative 4x minus 10. So our top equation, we had negative 4 as our coefficient. The bottom, we also have negative 4. So we have the same slope. But then if we look at the constants or the y-intercepts, we have a negative 5 and a negative 10, but different y-intercepts or starting points. So when they have the same slope but different starting points, that's going to give us no solution. They will never touch. All right, and that was it for number 2. All right, make sure you got this written down as well. All right, moving on. Number 3. 3 students each examine the system of equations below. Caleb says there is exactly one solution. Jeremy says there is no solution. Kim says there are infinitely many solutions. Which student is correct, and explain your reasoning. So again, what we're going to do before we try to say who's right, we need to figure out on our own what's the solution to this system of equations. So in order to do that, we need to go ahead and put both of these equations in slope-intercept form. So we'll need to move our 8x's to the opposite side, which means we're going to add its opposite. Both of them were 8x, so we'll have negative 8x on the other side. And then finally, I'm going to take off these things. All right, and then finally we're just going to divide everything at the top by 4 because we want that 4 away from our y. So we've got y equals 4 minus 2x. And at the bottom, we'll divide everything by 2. And we'll have y equals 4 minus 4x. So then if you're one who has trouble seeing that this is written in y-intercept form, we can always just change the order of it. So this one will be y equals negative 2x plus 4, and the bottom will be y equals negative 4x plus 4. Well, if you notice, both of these, might be a little too dark, yep. Both of these have the same, they have the same constants or y-intercepts, but that's never what we look for. We always look for the variable term or the slope. Well, if I'm looking at these variable terms or the slopes, this slope here at the top, the slope is equal to negative 2. At the bottom, the slope is equal to negative 4. Well, when you have different slopes, it's automatically going to give you one solution. Okay, and that's the student that said that it's going to be exactly one solution was Caleb. Okay, it was Caleb. All right, and that was all they asked us for number 3, and we're going to go ahead and move on. Okay, yeah. And of course, if they ask you, which I believe on the formative, we did ask you what was the solution then, since it was one solution, all you have to do is you can go ahead and graph it if you'd like. So we'll do that. So for the top one, we started 4 for both of them. We start at 4 for the top, and then we go down 2 over 1. Down 2 over 1. All right, so we've got this line for this one. Yeah, I drew that so wrong. Yep, there we go. And then the second one, we also start at 4, and then we go down 4. 1, 2, 3, 4, and over 1. 1, 2, 3, 4, and over 1. So both of them start at the same point. They have the same starting point, which of course is their y-intercept. Okay, so even before trying to graph it, you should have seen that they had the same y-intercept, which we kind of touched base on earlier. They both have the same y-intercept, and we know that y value is 4, and the y-intercept, the x has to be 0. So the one solution here would have been 0, 4. One solution at 0, 4. Okay. All right, and lastly, number 4, consider the following system of equations. Identify which system has no solution. So again, to do this, we have to make sure that every single equation in all of these systems is written in slope-intercept form. So I'm just going to go ahead and go for the one that's already written there in slope-intercept form, and that is my system 4. System 4 is already in the slope-intercept form of y equals mx plus b. So since that's the what we've got so far, we can go ahead and we know that one solution, which is what they asked, or I'm sorry, no solution means that, so no solution means that we're going to have the same slope, but different y-intercepts. Okay, so to put it in terms of what we've been using before, it'll have the same variable terms, but different constants. Okay, so if you look here, we have the same variable term, that part matches, and then the constants. Well, we have 3 here and we have nothing here. Well, if you have nothing there, it's just a 0. So I've got the same variable terms, but different constants, or the same slope, different y-intercept. So I've already found that system 4 is no solution, just by working a little bit smarter instead of harder. You didn't really have to go through any of these, but if that one wasn't ours, then we would have still done what we said we would do. So system 4 has no solution. Then it says then graph and label the equations. All right, so now we just got to graph it. All right, so I'll choose some different colors. Okay, so let's go ahead and do it. For the first one, I'll make that one blue. In the second one, I'll make it purple. Okay, so blue. All right, so we'll start at 0 for the first one. And then we will go, our slope tells us to move up 1 and over 2. Up 1, over 2. Up 1, over 2. And I can do the same on the opposite side from our starting point. I can go down 1 and over 2 still. Down 1, over 2, and down 1, over 2. And then I connect my points. Okay. Oops. Okay. Okay. And then I'm going to do the same thing with my next equation. So my next equation tells me to begin with my B, move with my M. So I'm going to begin at 3. So I'm going to plot my point at 3. And then I'm going to move with my M, which is my slope. I'm going to go up 1 and over 2. Up 1, over 2, up 1, over 2. And I'm going to do the opposite on the other side of my beginning point. So I'll go down 1, left 2. Down 1, left 2. Down 1, left 2. Okay, I'm going to connect my points. And we see that we have these. What kind of lines are these? They have the same distance the entire time. They maintain the same distance. They're never getting closer together. They're never getting further apart together. They maintain the same distance the entire time. These are a set of parallel lines. That's how you know you're correct. Okay, so we've done everything that was asked of us. We identified which system had no solution. We graphed that system, which further explained or further gave us proof that we were correct, that it is no solution, because parallel lines they have no solution because they have the same slope, different y-intercepts, so they will never intersect. And that was it for lesson 15, which was understanding systems of equations. All right, thank you.